This video is about one-way repeated measures ANOVA. So one-way means one independent variable or one factor. Repeated measures means the same participants will go through all conditions. For ANOVA, it can compare two or more means. And for repeated measures ANOVA, it's extension for dependent t-test. If there's only two conditions, one-way repeated measures ANOVA, it's same as a dependent t-test. So we're going to look at the example. We're going to look at if training will improve writing productivity. And there will be one group. The independent variable is the training across 3 weeks. The dependent variable is the number of pages written during the week, which is on the interval ratio scale. So we are going to look at the data. And here is the data. We have 5 participants, and we have the number of pages written for each week. And so each week there's a training. So we want to see that what the training effect on the writing productivity. For repeated measures data, there's a correlation relationship between the weekly number of pages written, and you would expect that those who are productive at week 1 will tend to be also productive week 2 and week 3 versus those who are less productive. So we're going to see that how we run the repeated measures ANOVA in SPSS. So for repeated measures ANOVA, go to Analyze, and then we use general linear model. Repeated measures. So the factor is the independent variable, which is a weekly training. So I'm going to just call it week. And it has 3 levels, 3 weeks. So I need to tell it's 3, and we're going to add this level. And then you are going to define it. So now here we can put all these 3 weeks in the within subjects variable box. And it's possible also to add between subjects variable. So for this one, we only look at within subjects variable. And then we're going to look at options and check descriptives, effect size, and then continue. I'm also going to look at the plots. So the weekly, I'm going to put a week in horizontal axis, going to add those. I'm going to keep this as a line chart. Yeah, so continue, and I'm going OK. In the output, we'll see that there's 3 within subject. The within subject variable is the weekly training. And we can see that the mean and standard deviation for the number of pages was written during a week. And we do see that as the weeks going on, there's more number of pages written during each week. And the test here, before we come to a test, there is also it's called a test for sphericity. And that is a test for the repeated measures ANOVA assumption test. So with repeated measures ANOVA, like here, the weekly training is, we would expect they are correlated, they are related. And the correlations are the same for the 3 weeks. So this is a test of that assumption. And so with the sphericity test, we're looking at the sigma value. So if the sigma value is larger than 5%, that means the assumption met. And so the correlation is the same across these conditions, which is the weekly training here. So if this assumption is violated, and we will use the epsilon to adjust the degree freedoms. In this the example, our assumption is met. And then the test is the within subjects test, which is here. And so we have, we're looking at the within subject is the weekly training. So for sphericity, so the assumption is met. So we'll look at the sphericity assumed this row. And also, yeah, so this is for weekly training effect. Yeah, so we'll read this row, and this is the error. Yeah, and we also read the error from sphericity assumed row. So if we look at this, yeah, so the weekly training effect, and we can see that the sigma value is less than 5%. So which tells us that there's a significant training effect. Yeah, so across the weeks. And this is the effect size, and tells us that 77.4% of the within subject variance is due to the weekly training. So since we have a 3-week training and we have a significant results, so we want to see that what is the difference between which weeks there's a difference. Before we come to that, we can also, because I did ask the program to give us a chart. Yeah, so there's a line graph for the weekly training. So this is the average number for pages written each week. We do see that the training, as the weeks going on, there's more pages written. And we do see there's a significant effect of training. So now we want to see that is the significance is between which weeks, and we need a follow-up test. So what we do is we go to analyze, we're going to rerun the repeated measures. And so this everything's the same. We keep everything same. So now we want to see the pairwise comparison. So we're going to here. We're looking at estimated marginal means. We'll put a week in here. And then we'll check, compare main effects and use the Bonferroni to adjust, because there will be multiple comparisons. We want to adjust the type 1 error that's within the 5%. So then I'm going to continue and then OK. And then so we will have a additional, so this is the marginal means, and this is the pairwise comparison table. So here, this each week is compared with any other week. So for here, we can see that week 1 compared to with week 2 training, and we do see that week 2 there's average one page more written, and this is but it's not significant. Okay, when week 1 compared with week 2. If we compare week 1 to week 3, and we can see that week 3 on average there was 2.8 pages that's written. Yeah, so and this is significant, which is flagged by the asterisk. And you can also tell the sigma value is less than 5%. And there is additional one, which is comparing week 2 and week 3. And this is also significant. And so here, the p-value less than 5%, and also this is asterisk. And can see that the week 3, it has average within 1.8 pages more. So there is a significant weekly training effect. And the difference is more due to there's no difference between week 1 and week 2, but there's a difference between week 2 and week 3, and also the difference between week 1 and week 3. This is the end of the tutorial. Thanks for watching.